Morning, everyone. So, uh, today is day 6, Wednesday, June 4th. Um, here in Canvas, uh, we've got a couple things. Uh, we have Chapter 2, Project 7, and then Chapter 3, review worksheet, and then for June 9th, you're going to want to do the 4.3 lecture notes. Um, Again, we mentioned on Monday that you're totally allowed to work ahead. You don't have to wait for me to tell you, go look at, the 4.3 lecture notes. So some people have already finished it, which is great because we are going to use those that material in uh, Elaine's class tomorrow. So if you haven't finished your stuff from Monday, you still have time today. It's due today at 6. So if you haven't finished the Chapter 3 Project 1 or the Chapter 2 project that we did in class on Monday, you still have time to finish those. Um, and then we talked also last time about the testing center for the midterm, which is coming up June 25th. I'm going to be sending out a poll. I haven't decided if I'm going to send that as like a Google form or in Remind, just so I know what people's plans are. You can totally change, but it helps to give the testing center numbers ahead of time. I know how many tests to send over and so on. Like I said, you can change your plans if you need to. Um, okay, our plan today, we're going to do the project and we're going to do the review. But we're going to mostly do those together as a group. Um, so uh, we're probably not going to split up into separate rooms. We'll probably work on them together here, but I'm going to start with the chapter 3 review, and you're going to find that on page 306 in your course pack. Okay. So, uh, yeah, start pulling out. So it's 4 pages, page 306, 307, 308, 309, for the chapter 3 review. Okay. Um, you can also pull it up in Canvas here. Um, but you're going to want to write your answers on the paper. Um, but in Canvas, there is a link for the Chapter 3 review worksheet that's going to give you that data set in StatCrunch. Okay. So, because there's a couple of things that we'll need to do, like getting in the mean, median, mode, where you're not going to want to, do that yourself. Add up all the numbers, divide by how many numbers there are. That gives you your mean, right? Median, you have to put them all in order. I don't want you to have to rewrite all of them. So StatCrunch can do a lot of that for you. So here in Chapter 3 review worksheet, if I click on this link, it's going to take me straight to StatCrunch where I've got all the numbers already entered in here for me. You'll want to sign in or register because otherwise all this stuff here is grayed out. Okay. So, but um, we're gonna work on this together. Uh, let me jump over here. So here it is, Chapter 3 review worksheet, page 306. Um, so as I mentioned, we're gonna have this finished by the end of the class today, and we're gonna mostly work on it together. But I'm gonna give you some big hints, so that you don't have to so you're not super lost. Um, we have this data set here. Following data set shows the ages of a random sample of business executives in a conference. Okay. Um, So find the following. So X bar, P50, whole bunch of different stuff. Okay, find all of these. Okay. Um, X bar, you'll remember, that is what we call the mean. Okay. So to find the mean, you add up all the numbers and divide by how many numbers there are. Okay. And again, StatCrunch can do that for you. Okay. So P50 is the median. Okay. It's also known as Q2. Okay. So Q2 is quartile. So quartile is if I was to break my data up into four pieces, four quarters. The second quarter is going to be right in the middle. Okay. And that's why it's the median. Okay. P50 is the 50th percentile. So if I was to break my data up into 100 different buckets, 100 different percents, the 50th one again is right in the middle. Okay. That's our median. Um, Mode is easy. That's the one that's the most, right? N, that's your sample size. Okay. S is your standard deviation. Okay. Standard deviation, you can think of it as the average distance away from the mean. Okay. So these numbers are not all the same, right? So how spread out are they? Well, the easiest way to answer that is find the middle, which we call the mean. Okay. And then find out how far away each of these are away from the mean and then average those. Okay. Um, S squared is basically the same as standard deviation, but it has a different name. It's called the variance. Okay. This is the minimum, maximum. Okay, those are easy. The 25th percentile. So if I break my data up into 100 different buckets, the 25th one is going to be the first quarter. So this is Q1, quartile one. Same idea with the 75th percentile. That's the third quartile. Okay. Range is the minimum minus the maximum. Interquartile range is Q3 minus Q1. Okay. All right. So we're gonna have StatCrunch do all that for us though. Okay. So um, you don't have to add up all these numbers and divide and the standard deviation formula, like it's crazy, right? It's complicated, okay? But it's super useful. Okay. All right. So lower fence and upper fence. Those you'll find in the notes on page 84. Okay. Or the lower fence and the upper fence. Basically, um, how far out do we consider an outlier? Okay. Um, so if we have a number in here that is very different from the rest, well, how do you decide if that's very different, right? Um, so obviously if you have like an eight, so this is business executives in a conference. So an outlier might be someone who's 18 years old. Like that's uncommon, right? Or someone who's 100 years old. But where do we actually put that line to say, okay, this person is part of an outlier? So that's what these lower fence and upper fences are. Okay. Um, are there any outliers? So we just described that. So it's basically just past the fences. Okay. Do we have any numbers past the fences? Okay. Um, what appears to be the shape of the distribution. So uh, we don't need to graph this. Okay. On page 87 in your notes, we talk about how to tell. Okay. So make sure you explain how you figured that out. Okay. Um, right. There's basically we compare the mean and the median, right? Which one's higher, which one's lower. Um, What measures of central tendency and spread should be used when reporting about this data set? Again, page 87 in your lecture notes. Make sure you explain. Okay. Find the z-score of a executive who's 41 years old. Is this unusual? Okay. Explain using the z-score. Now that um, so that you'll find in the lecture notes on page 231. It's actually not the lecture notes. So page 231 is the start of the exam notes packet. Okay. So we're going to start looking at that and making sure we understand what's on there because you can use that in the exam, right? It's a yellow section in your course pack. Okay. So uh, explain using the z-score. So page 231. Okay. All right. What does unusual mean? Okay. You'll find that on page 231. All right. Next page. Okay, here we go. The box plot here shows the payrolls, amount of money paid for all major sports teams in the US in 2018. Okay. So, um, box plot is one way to look at our data, okay, where it's basically using the five number summary. So this point right here is your minimum, and then quartile one, median, quartile three, and then the maximum, right? And we might use some stars if there's outliers, okay? So which sport had the highest average? So for that, you'll use the median, okay, which in this case is the center line. So the center line of each of these boxes. Okay. Which sport had the smallest range? So range was maximum minus minimum. Okay. Which sport had the largest spread? Uh, so the IQR is Q3 minus Q1. So Q3 is this line here. Here's your median. Q1 is this line here. So Q3 minus Q1 is basically the width of the box. Okay. Whereas the range, max minus min, is here's your max, here's your min. That is the length of the whole thing from start of the line all the way to the end of the line. Okay. What was the shape of the distribution of hockey payrolls? Okay. So uh, we talked about how to tell that on page 86 and 87, okay, of your notes. Okay. Because here, so we talked about like, okay, if you have a histogram, it's easy to see like, okay, does the ta tail skew off to the left? Does it skew off to the right? I don't have a histogram here. I have a box plot. Okay. So if I have a mean and a median, I can compare which one's higher or lower. I don't have means here. So on page 86 and 87, we talk about how to tell based on this. Okay. Um, all right. So make sure you include units on these ones. Part G, explain using the graph. Which sport do you think has the largest problem disparity in team payrolls? Okay. So I'll ask this one for you guys. Which sport do you think has the largest problem regarding disparity? Disparity means differences in team payrolls. So looking at this box plot up here, baseball, basketball, football, or hockey. Which one do you think has the biggest differences in payrolls? Baseball. Yep. So football's got a couple of outliers, but baseball is the answer here because the range is so large. So that means that there's some people making, $210 million dollars and then some making, down here at $60 million dollars. So there's a very wide range in player values. Okay. The problem with that is, uh, right, this means, right, this means that poor teams will likely have weaker players and be unable to compete against rich teams. Okay. Right. As an analyst, like if we just are giving you the numbers, we might not necessarily be, helping you figure out what the problem is or how to solve it. Right. So why is there, so with football, like the range is with these outliers is probably a problem, but most of the teams fall in this range right here. So you might have a team that doesn't have a ton of money, but they aren't going to be spending that much more than someone who is able to afford much richer, much more expensive players. Baseball, on the other hand, uh, for years they've said like that this is a major problem because you always see the same teams in the World Series every year because they can afford them. They can afford better players. All right, part H. Explain what this graph shows about the payrolls for the different sports and compare to each other. So you can put a couple different answers here. Um, Basically, we're just comparing the different groups. So um, one thing that jumps out at me is like these medians are about the same, but the hockey one is way lower. So I'm going to put that hockey uh, players make significantly less than other sports. Okay. If you want to compare other ones, that's fine. But all right, all right, page 3. All right, so page 3, we have a table here with a bunch of different classes. And this, if I jump back over here to Canvas and go back to our course, um, this is the other project, the project that we have today, which is Chapter 2, Project 7. So when you get to this spot, we can take a pause, come over here and open up Chapter 2, Project 7, open up the instructions, and then there'll be a link that brings you to the data, right? And then we can fill in the class midpoints, relative frequency, cumulative frequency, all that good stuff that we've been doing before. Do all this, submit this project, okay? And then once you've done that, we will jump back over here to the paper and we can answer the questions down here. Okay. So how many countries and territories participated in this? What's the population and so on. Okay. So, all right. So what is this table? So this is the frequency distribution of all athletes participating in the 2016 Summer Olympics. Okay. So that means that since this is all of them, this is our population. Okay. We're not taking a sample here. Okay. So what is the population? The population is all participating countries. Okay. What type of variable is the number of athletes for a country? So we talked about this on page 9 of our notes. Um, but we can answer this one right now. So, what type of variable is the number of athletes? So, qualitative is usually words. Okay, it can be numbers. Uh, Quantitative is numbers. So number of athletes. So, US might have had like 300 and Greece maybe they had like 58. All right. So that is quantitative, okay? Because you can add up those totals. You can do a comparison. Uh, so it's a quantitative variable. Discrete means you're not allowed to have decimals, and continuous means you can. So, can you have in this class, we have 50 to 99, can you be at like 65.8? No, you can't have 65.8 athletes, right? You can't have half of a person competing in the Olympics, okay? Um, so since that means that you have to have whole numbers, it's going to be discrete. Okay. Continuous means you can have decimals, you can have fractions. Okay. It's the lower limit. What's the class width? That's fine. Uh, part F, what's the class width? Part G, how many countries had 300 or more athletes? So since we're asking how many, we're asking frequency here. Okay. For part H, what percent? Percent means we're looking at relative frequency. Okay. Um, What's the modal class? So modal is mode. Okay, so it's the one that had the most. So class with highest frequency. Okay. What appears to be the shape of this distribution. So in the project for chapter 2, we're going to create a histogram, so you can just use the graph for that. Okay. So find the mean and the unadjusted standard deviation of this distribution. Okay. So uh, if I have a list of numbers, then I can do a standard deviation. StatCrunch can do that for me. Okay. Here I don't have that. I have a bunch of classes and frequencies. Okay. So you're going to find this on page 232, which is again in the yellow section, the exam notes. Okay. And there's a couple different methods there. We're going to use method 2. Okay. Method 2 is the one you would use if you have a bunch of buckets, a bunch of binned groups, and some frequency counts for them. Okay, on how to find a standard deviation, and it's going to go off the class midpoints. We've been doing class midpoints on a bunch of different projects. Okay, why do we need them? And now we'll see that. Helps you do your standard deviation, okay? Um, oh, and then after you found those numbers, then you need to interpret those in the context of the situation. So to do that, um, you're going to use the uh, you're going to use on page 231, again in the exam lecture notes, you're going to use the give or take phrasing. You're going to use the give or take script that's there. Okay. So it's, you know, the script that we're talking about here is the one that says like uh we expect that the variable to be the mean, give or take, standard deviation, right? So you're going to use that give or take script here because we're interpreting. Okay. All right. Yeah, one more page and then I'm gonna turn you loose on this and you guys are gonna crush this worksheet, okay? All right. Last page is this guy right here, page 4, and this says that the birth rate of babies in the US is normally distributed with a mean and standard deviation. Okay. So normally distributed is going to look like this. Now, this this is a line graph, right? It's actually a histogram with like a bunch of, bunch of classes, a bunch of rectangles. It's just that you might have so many rectangles in here that it's easier just to draw the tops of the rectangles and you end up with a shape that looks like this. Okay. So right here at the highest spot, this is the mean. Okay. And then from here to here, okay, this is, you're going to write the number, okay, for each of these spots, okay? And from here to here is what percent. Here to here is what percent. Okay. Each of these distances is a standard deviation. Okay. Erase that. Just put. All right. So you're gonna put a number in each of these spots. Okay. Um. Okay. So this, by the way, this is on page 231. Um. So once you've got that set up, and you've got these numbers, it's easy to answer this one. It's easy to answer this one. So, what would be unusual for a baby to weigh? Would it be unusual for a baby to weigh 9 pounds? So, what do we mean by unusual? You'll find that on, again, on page 231. Okay. Okay. So that's question 4. We usually on the worksheets will often have like one question with many different parts on the same worksheet. Uh, Question 5 down here is not about the same picture. Okay, so you can kind of think, okay, this is a new question. So, uh, true or false? The mean is the score at the 50th percentile. Um, no, the median is the score at the 50th percentile. We mentioned that earlier, right? P50 is Q2 is the median. Okay. False. Because the median is P50. Okay. And that was on page 83 in our notes we talked about. Okay. Standard deviation of a data set cannot be negative. Okay. So standard deviation we talked about on page 68. Uh, can the standard deviation be negative? So S is greater than or equal to 0. Okay. So, uh, yeah, it's true. Um, your standard deviation is always, it could be zero, okay, but that's not negative. It's allowed to be positive, and the reason why it's never negative is because we square it. There's a square in the calculation somewhere where you basically, if you take a negative number times itself, it's positive. You take a positive number times a positive number, it's still positive. Okay, so it's always going to be bigger than zero. If the median is significantly smaller than the mean, the data set is negatively skewed, right? We've talked about that before, page 87. So that is false. Okay. So I'll give you the answer, but I'm gonna leave the why for you guys. So because why? Okay. I'll let you fill that in. Okay. All right. So I've given you no answers, a couple answers. I've given you hints. Okay. So what I'm gonna do though is I'm gonna stop my screen share, and I'm gonna leave it up to you guys to uh work through these problems on the worksheets as well as the project. And Elaine and will be here to make sure you get the right answers, make sure that if you get stuck, we can jump in and help you out, okay? But otherwise, I want you guys to work on these and and see how it goes, okay? So I'm gonna probably leave the recording on if that's okay, for other people to watch later if they need, or if you want to watch it later because you fell behind or anything. So, all right, I'm gonna mute for a moment. So, Laura, Michaela, and Tim, are you able to get into StatCrunch with and get the numbers for question number one on the worksheet? Yes. Okay. And does anyone remember how to in StatCrunch calculate all these things on question number one? So mean, median, mode, sample size, all of that. Does anybody want to share their screen?
The Nintendo Switch 2 is launching June 5th for $149. Yes, it is the most expensive Nintendo Switch to date. So let me know if you're going to plan to pick it up. Nintendo Switch 2.
Um, yeah, I mean, Laura, if you want to work on the last page first, that's fine. But I think it'd be easier if everybody's working on the same page. So, can we start with number one? Is there anyone who wants to share their screen? Thanks, Laura. Awesome. Okay. Yep. So you need to sign in. Yep. Hmm. Yep, we need that one. Yep. Do we need the mode? We do need the mode. Yep. Hmm. Very nice.
Okay, so I just went ahead and selected the ones I was missing and
Yep.
got all of this. So
Okay.
now I can fill it in my chart real quick.
Yeah.
And it says 3 decimals, so I'm guessing we'll just round that.
Yes. So 49.667
Mhm.
for the mean. We know when you guys get part A all filled in, then we can talk about how to do part B.
So I'm done. And I already have the formula for the next parts. So I was going to use Desmos.
Great.
So I'm just doing the Q1 minus 1.5 times IQR, which is 23.5.
You got it.
And then the
So
next
that's
one is
the lower fence. Yep.
yeah. Upper fence is Q3 plus 125 times IQR. So 56 plus 1.5 times 13. 75.5.
Great.
All right.
This all making sense to you, Alejandro and Michaela, Tim? How she got those fences? Part B and C? Yes? Great.
All right. And then to look for outliers, we're looking for anybody below 23.5 or above 75.5.
Okay.
So 23.
So what was the minimum? Do you remember?
The minimum is 28.
Yeah, so that means that there's nothing below 23. So you don't have to look through the list, right?
Oh, okay.
Um, what's the maximum?
The
That's
maximum 1.
81, and
Mm-hmm.
that is past the fence. So definitely the 81 is an outlier, but you will have to look through the rest of the numbers to see if there's anything else past the fence. So But for the minimum, like there's no point in even checking because your lowest number was 28, right?
Mm-hmm. Yeah.
Okay.
So I'm just showing 81.
I agree with that. Yeah, this list isn't too long. If the list was really long, yeah, there's other ways we could have searched for it. But yep. So for this one, are there any outliers? Yes. 81 is higher than the upper fence.
Mhm. Okay. So I can do, I think, all of these, right, to do the graph and a histogram. Oh. Um, and this tells me my shape, which I guess we're kind of in the middle there because of that outlier. It was more skewed left until we had the outlier.
Alejandro, what do you think the shape of this is? Yeah, the shape. Is it skewed left, skewed right? Yeah, you're right. It's symmetric. I agree. And we didn't necessarily have to graph it. We could have compared the mean and the median. Our mean was 49.6. Our median was 49. Those are really close. I would call that symmetric.
All right. The next one is what measures of central tendency and spread should be used when reporting about this data set? So, um, let's see, page 87. So, the better measure of center for symmetric is mean. And our mean is 49.667. To measure the spread is the standard deviation. And since it's a, let's see, it's a random sample. Okay. Let's see. Yes. So our standard deviation would be 10.509, and that would be the better measure of spread for a symmetric distribution. Am I on the right path there or no?
Um, Michaela, is she on the right path? think so, yeah. Um, so there's three ways to measure the center: mean, median, and mode. And we've talked about three ways to measure the spread: standard deviation, range, and interquartile range. So, um, for this question for F, what measures of central tendency and spread should be used? Um, so you're going to pick one of the centers, mean, median, mode, and one of the spreads, and explain why we would use those. And there's two answers here, and either one is fine. It sounds like you're saying that we should use mean and standard deviation, which I'm good with. Okay. The reason I'm good is because as you mentioned, Laura, it's symmetric. If it's symmetric, then mean and standard deviation are great. If you had instead said, I think we should use the median and the interquartile range because it resists skewed data, that would have been a good answer too. I like your answer, Laura. So mean and standard deviation because it's symmetric.
That was a tricky problem because you had to do both.
Yeah.
All right, last one is find the Z-score of an executive who is 41 years old. Is that unusual? Explain using the Z-score on page 231, so our yellow pack. So Z-score is parentheses value. Oh, sorry, X minus mean divided by standard deviation. So let's see. So we got to use X. What would X be? Oh, wait. This says for a sample, use X minus X bar over S. X minus X bar. That's the same thing. Okay. So I know the mean is 49.667. Standard deviation is 10.509. But I guess I don't know X. Oh, wait, X is 41.
Yeah, you
I
got
do
it.
know X. All right.
Yeah, so in the formula on page 231, the mean is going to be, sometimes we call it mu, sometimes we call it X bar. I don't care what you call it, it's the mean, and it's going to be the same every time. The denominator S or sigma, again, same thing. But X is going to be dependent on what you're trying to get the z-score of. So in this case, we're trying to get the z-score for someone who's 41. Um, so your X is going to be some number from the data set. Yep. So negative 0.825 if we round it
Yep.
to three digits.
Now we have to explain, or we have to see if it's unusual.
Yeah.
So
Is it
unusual
unusual?
is anything beyond 2 standard deviations from the mean that would be considered unusual. So our mean is 49.667 and our z-score is negative 0.825. Or would we be using X for that?
Tim, how do we tell if this is an unusual uh, result? You there, Tim? Alejandro or Michaela? How, you want to jump in? How do we tell if something's unusual? Elaine, you want to help us out? Oh, there we go. Alejandro, 2 standard deviations from the mean. Okay. So is this one 2 standard deviations from the mean or not? If there's a significant deviation from the expected outcome. Okay. You want to help us out, Elaine?
Don't forget, it's on the page of your yellow sheets. It'll tell you. And Z-score is a number of standard deviations from the mean. And a positive is above the mean, a negative is below the mean, but it's still a number of standard deviations from the mean. Should be right in your notes.
Yeah, so that's what the z-score means. The z-score is asking how many standard deviations away is this example. So 41, how close to the mean, how close to 49.6 is it? Well, it's negative zero point 0.8 standard deviations. So really, if you want to measure if something's unusual or not, it's really just asking, do you have a z-score that's bigger than 2? So is the
Oh,
z-score that you got, is that bigger than 2 or is it less than -2?
it is less than, or no, yeah, it's less than 2.
Yeah, so since it's less than 2, it's not unusual. Okay. If you got -3, then I would say, yeah, that's way bigger than negative. That's way bigger. So an unusual number would be a z-score of negative 2.1, 2.5, 4. So no, this is not unusual because the z-score uh, is under 2. Does that make sense? Any number
Yeah.
between -2 and +2 for your z-score means it's in the main bulk of the data set. It's not unusual. So the 81 we saw earlier, that was an outlier. That one's going to
Mhm.
have a crazy high z-score. Okay. And that one is going to be considered unusual. We're not going to calculate the z-score for that one, though. We're just going to move on. So nice job. Page 2. Page 2 is the sports one. So which sport had the highest average?
All right, so we want to look at the center line and the median. So it looks like basketball had the highest average.
I agree.
Looks like it's at.
Yeah, you
I
don't
don't
have to
know how
tell us
many.
what it is. Yeah, for this one, I just want basketball
All right.
for question A.
Which sport had the smallest range? So the max minus the minimum. So we got. I would say just visually it looks like basketball.
Yeah,
If we
yeah.
don't want to know the
You don't
numbers.
actually have to do the math. You can just look at which lines are the closest together. So yeah, it's absolutely basketball.
And then which sport had the largest spread? I would say baseball.
Mm, yep, that was the width of the box, and baseball has the biggest box.
And then what is the shape of the distribution of hockey payrolls? I would say that's skewed left because of the longer tail on the left and that little outlier there.
Yep. Yeah, you got it. Skewed left.
All right, 25% of baseball players are less than, including units. So baseball players is the first one, and then 25% from, let's see, quarter one or quarter two to quarter one.
It's just less than 25%.
Oh, less than 25%. So then that would be uh, that would just be that line there.
What quartile?
25% would be quartile one.
Mhm.
So we'd be at like 95 million, I guess.
Sounds good. So for question E, uh, 25 million, or sorry, $95 million. Yep. Because that's where Q1 is, right?
Mm-hmm.
Mhm.
All right. The Dallas Cowboys NFL team had a highest payroll of. So the NFL is football. And if they're the highest, I guess they would be at the 150 million
Yep.
at the
And
outlier
we can
there.
answer that because we've got that star there because it's an outlier. If you just had the line, like if we, if we said that it was somewhere in the line, you wouldn't be able to tell. But yeah, since you got the star there, it's
Yeah.
$150 million.
Okay. And then I think we kind of already went over the other two, but
We did answer
um,
those already. Yep.
okay, yeah.
So
All
should we move
right.
on to page 3?
Yeah.
All right. So I would suggest pausing here for page 3 and then going and filling out the chapter 2 project. Yep. So it looks like you've got most of it in here already. Um, Something went sideways with your class midpoints, it looks like.
Oh, let's see. Last midpoints. Hmm.
Because the midpoint is supposed to be the number right in the middle. It's actually the median of the class. So if
Mm-hmm.
I look at the numbers from 50 to 99, which number is right in the middle between 50 and 99? And you have an answer of 125. Well, 125
Oh,
is higher than 99. So your midpoint
oh,
should always land in the class. So clicking
okay.
in
So
that
no, my
cell, what
formula
do
is
you got?
wrong. So I did
Ah,
this plus that. I must have did that wrong.
Parentheses.
so Michaela, do you see where she went wrong in her formula? Can you help her out?
One of the
You know what we're
oldest
missing?
problems, the order of operations.
She has equals 100 plus 50 divided by 2. Do you already know where you went wrong, Laura?
Well, I think Elaine kind of slipped it out, the parentheses. All
Yeah, you got it. So you need
right.
parentheses. Yep. There you go.
Okay. And then
75 should
there
be
it's
second.
already
You got it
plus.
right, Michaela. And then, yeah, you'll copy that down. Yep.
All right. Now I got to
That
update
was
my
good.
chart here.
Well, that shouldn't mess up the chart because the chart is not off of class midpoints. The chart that you, oh, you mean on the
No, but I
paper.
already
Yeah.
wrote it on my paper, so I got to update my paper.
Fair enough. Yeah. I thought you meant the graph on there, the histogram chart.
No, thankfully I didn't mess that part up. And I'm just going to do.
Can you click on cell B2 for me? I want to make sure we got the right formula in there. Yeah, you got it. You're good.
And then this is the same plus.
Mhm. All right. So uh, for for this, it looks like you did great on the project. So make sure you share it and submit it for the Chapter 2, Project 7. Um,
Mhm.
Michaela and Tim, were you able to do the project, or is there anything we need to go over? It's it's a similar steps to what we've done before, but looks like Laura's already got it finished. So, um,
Sorry.
well, that's okay. Um, all right. So jumping back to, you don't have any questions? Nice. All right. Jumping back to the course pack on page 308, the worksheet that we were working on. Question number 3, uh, part B was asking how many countries and territories participated in the 2016 Summer Olympics? So how many total were there?
We got I got 206. Let me just go back here.
206. Yep, you got it.
206. And then we already did C, which was what is the population in all participating countries.
We did
And
C,
D,
we
we
did
did.
D.
hmm the lower class limit of the fourth class is 150.
Hmm. Yep.
Class width is 50. How many countries had 300 or more? So these, I counted 11.
Yep. Makes sense because if you highlight those in the lower right-hand corner, you can see that it actually adds them up for you.
Oh, yeah, nice.
Uh,
What percent of countries had between 100 and 149 athletes? And so we got 14, and that would be 6.8%.
I agree.
All right. What number of athletes is the modal class? So the most. Um, let's see, modal class, number of athletes. I actually did that. So we would be at,
Remember, the definition for modal is highest frequency.
yeah, so okay, I did it right. So 147, I put under 50.
Under 50, you got it. So the answer for part I is under 50. That's the name of the class. Yep.
And then, oh, I don't know where there it is. So the shape, it is skewed right because the tail goes off to the right.
Very skewed right. Yeah.
And then I didn't do this part yet. Let's see. Find the mean and unadjusted standard deviation. Let's see. So page 232. We're going to do method number 2. So frequency
Yeah.
distribution. We're going to go to StatCrunch. Oh. Just open a new StatCrunch. All right. Oh wait, was this part of this?
No, that one was the executive ages. So yeah, so we're gonna go to StatCrunch. So start with going to the Google Sheet where you've got that data. Yep.
Okay.
And so we need the midpoints and the frequencies, right?
Okay.
So can you
So,
click on the B at the top? Yeah, highlight those. Yep, you got it. So you're gonna click and drag and paste those there. And then we need the frequencies as well. So do the same thing, click and drag, copy, paste. You got it. Okay.
all right.
So
Easy
now
peasy.
that now that you have that, according to the yellow paper, you're going to do select stat, summary stats, grouped slash binned. Okay. And you're going to have to select which one is your bins. So variable 1 and counts is variable 2. Now we really just we need the mean and the standard deviation. You don't have to clear anything here, but yeah, you can. And then control is the standard deviation.
We want the
Well,
unadjusted.
yeah. Yep.
All right. So the mean is 65.5, just one decimal place. And then unadjusted standard deviation is 90.4. Interpret their values in the contents of the situation. So we're going to use our script on page 231. It'll say
At the
we
top.
expect, or wait.
Yeah, you got it.
Oh yeah, give or take. Wait, hold on. Yeah, that's right. The we expect script
That's correct.
or
Yep.
mean and standard deviation. Okay, so we expect the data variable written in the contents. So this is the following frequency distribution shows the number of athletes for all participating countries and territories in the 2016 Olympics held in Rio de Janeiro. So we expect number of athletes.
We expect the number of athletes for a country to be 65.5.
give or take.
give or take 90.4 athletes. Yep.
All right,
All right.
there we go.
Michaela and Tim, do you want me to repeat what we said there? Were you able to write that one down for Kay? Very good. All right. Sounds good. Let's move on. Last page.
Okay, I don't think I need to share my screen anymore, so.
That's fine. Yeah.
You did a good job.
Thanks. Am I still sharing? I can't tell.
No,
Okay.
we can't see your screen now. No.
Okay. All right. So I already filled out my little chart here
Okay.
and did all the numbers and the percentages.
Okay. So what'd you get for the mean? Mean is 7.17, right?
Uh-huh. Yep.
And then percentages, you got like 34%.
Yeah, it's 34, 34,
Yep.
13.5,
13.5, 2. Yep, you got it.
2.35. Yep. Hmm.
All right. Good stuff.
Yeah.
All right. Well, then we can move on to B then. Roughly 95% of all newborns weigh between what and what?
Well, 95 would be two standard deviations. So it would be 5.51 pounds and 8.83 pounds. What percentage of newborns weigh less than 5.51 pounds? It would be, let's see, 2.35 plus 0.15 be 2.5%.
Is that for part C, you had 2.5%? Yeah, I agree with that.
Yep.
Okay.
And then the percentage of newborns weigh between 6.34 and 9.66. I'm getting 83.85%.
Michaela and Tim, is it making sense how we're getting these numbers? That's 13.5. All right. What'd you get for E? Would it be unusual for a
Um,
baby to weigh 9 pounds?
I
So
said
nine,
yes.
what's that?
I said yes
So nine's gonna
because,
fall right around here, right? Here's 8.83, here's 9.66. So go ahead. What were you gonna say? Why you say yes?
sure, sorry. I put 9 pounds is more than two standard deviations away from 7.17 pounds. So it's in that third deviation bracket.
Yep. You're right. So here's one, here's two. So you are absolutely right. Since our z-score there would be more than two. Yep. You don't have to write z-score, but since it's more than two standard deviations away from the middle, then yes, it's unusual. 9 pounds is a heavy baby, right?
Yeah, no kidding.
Read that 2.35%. And then we did number 5, part A. We said false because the median is the P50, not the mean. We did part B. We said true. We didn't do this last question, so
Oh, good thing you said that because I didn't notice it. All right.
oh, I said go to page 87 to look up how to tell if something's negatively skewed. What is it? I'm having in front of me what that says.
All right. So if the median is smaller than the mean, that means it would be, uh, hold on. Yeah, it'd be skewed right. Let's see.
We don't always talk about it this way. That one is saying negatively skewed, which
Yeah.
is one direction.
So that would actually be skewed left,
Uh-huh.
right? Yep.
Yeah.
So I would say because a negative skew is, oh, you're writing it, is,
I'm writing what you were saying. So negatively skewed is skewed left, which
mhm, would mean the
would
mean is less than the median.
correct. It would mean that the mean is less than the median. That's not what we have here. We have that the median is significantly smaller than the mean, right? So that's the wrong order. Make sense?
Yeah.
Okay. That's what I would put. All right, that's what I did put.
All righty.
All right. So I'll stop the recording. That's all